Welcome to this video about steam locomotives in the Harz Mountains, covering their history, technology, and legacy, from mine pumps to tourism. What is a steam locomotive? It's a vehicle powered by steam generated in a boiler, often by burning coal. This energy is transformed into mechanical motion for the driving wheels. Key elements include the boiler, firebox, steam cylinders, crank mechanism, and driving wheels. Steam locomotives were once the most common means of mechanical transport, used for carrying people and goods on public, industrial, and narrow-gauge railways. The mine pump was the technology that started it all. Flooded mines were a problem in the 17th and 18th centuries. The solution was the steam pump. Thomas Newcomen introduced the first practical steam engine in 1712, where steam moved a piston, which, in turn, moved the pump. Mining and coal were the cradle of the steam age. James Watt's improvements included the centrifugal governor, a mechanical device that automatically regulated the operating speed of the engine without human intervention. This allowed for stable steam usage by reacting to speed changes, thus controlling the steam valve. George Stephenson's rocket was a pivotal steam locomotive designed for the Rainhill trials in 1829. It ran on the Liverpool-Manchester Railway, and its purpose was to find the best functioning steam locomotive. The rocket introduced key technical innovations: a multi-tube boiler for a larger heating surface, steam ejection to the chimney, blast pipe, for better draft and more effective combustion, and direct movement of the axles, reducing energy loss. These elements became standard in later steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour, weighed around 4.3 tons, and used coal as fuel. Its wheel arrangement was 022. Compared to the 1820s, these achievements were revolutionary. The rocket was the winner of the Rainhill trials and established the construction model for the steam railway. It proved that steam rail transport was safe, efficient, and profitable, beginning the era of modern rail transport. The formation of coal took millions of years from plant remnants under pressure and heat. It transformed from peat to brown coal and then hard coal. The abundance of coal increases with depth and age. Coal became the main fuel for steam engines and industry. The evolution of extraction technology saw surface and underground mines in the 18th and 19th centuries, initially with manual extraction. Later, mechanical hammers, steam pumps for draining mines, and mine railways for coal transport were introduced. This increased the availability and lowered the cost of raw materials. Coal processing involved classification by quality and calorific value, followed by coking. Coke was then burned for metallurgy and heavy industry. Steam locomotives and industrial machines needed high-quality coal with a high calorific value. Comparing the caloric value of fuels, brown coal is about 12 to 20 megajoules per kilogram, hard coal about 24 to 30 megajoules per kilogram, and oil about 42 to 46 megajoules per kilogram. Coal was cheaper and more readily available in the 19th century, despite oil's higher caloric value. Major coal mining centers in the 19th century were found in Britain, specifically in Lancashire, Yorkshire, and Durham; Germany in the Ruhr region, Saxony, and Rhineland; the US in the Appalachians; and France and Belgium around Charleroi and Nord-Pas-de-Calais. These regions fueled the development of steam railways and manufacturing industry. Coal was the ideal fuel for steam locomotives due to its high calorific value, which produced powerful steam. It was also easy to transport and store in stations and wagons, and readily available across Europe and America in the 19th century. Without coal, steam locomotives could not function effectively. Steam locomotives enabled the rapid transport of coal from mines to cities and factories. This led to the first railway lines dedicated to coal transport. Local mine railways efficiently linked mines, factories, and ports. Steam locomotives accelerated the pace of industry and the availability of raw materials. The steam locomotive's significance for the Industrial Revolution included providing a stable energy source for factories and accelerating commerce and urbanization through railways. The combination of coal and steam was the driving force of modern industry. The locomotive was a catalyst for economic changes in the 19th century. The challenging terrain of the Harz Mountains, with steep slopes, deep valleys, and sharp curves, presented a challenge for building railway lines. The task was to construct tracks and adapt steam locomotives to the mountainous conditions, requiring special technical solutions. Technical adaptations for steam locomotives in the Harz included narrow-gauge engines, reinforced boilers and brakes, and special cogwheel systems for better traction on steep slopes. This ensured safety and stability during the transport of goods and passengers, allowing the locomotives to function effectively in mountain conditions. The Harz narrow-gauge railways form a network of mountain railways over 140 kilometers long. Steam locomotives have been used there since the 19th century and are still used today for freight transport and tourism. The Harz narrow-gauge railways are a living museum of steam rail transport. Historical examples include the 995901 Brockenbahn, which runs to the highest point of the Harz Brocken, and the industrial narrow-gauge locomotive 9972456. Locomotives from the 1920s to 1930s transported coal and wood in the region. All demonstrate the evolution of steam technology in challenging mountain terrain.